Welcome to CrypSwing. This is Aaron Bittman, software developer. Before I get to the program itself, I should explain the version history in case of confusion. I wrote CrypSwing version 1 to demonstrate my Java skills and to learn about swing classes in 2019. In 2020, I wrote another version of Crypt in Python, this time adding more features, making it more powerful. But then I switched back to Java and added those features to the Swing version, plus even more features, making this one my latest and greatest in 2021, at least until I add those features to my Python version as well. So, with that explanation out of the way, let's get to the point. What is CrypSwing? Back in the 20th century, I enjoyed solving cryptograms in magazines like this one. Cryptograms are messages encoded with a monoalphabetic substitution cipher. In other words, one letter in the English alphabet would be substituted with another letter or symbol. The message in code is called ciphertext. The plain English to which you translate the encoded message is called plaintext. So for instance, if a plaintext A is written as a ciphertext C, then a plaintext A will always be written as a C throughout the message. Of course, solving such problems with only a pencil can sometimes be difficult and tedious. When you guess that a ciphertext symbol represents a certain plaintext letter, you have to search the whole puzzle for all occurrences of that symbol to translate it to the plaintext letter. If you later change your mind, deciding that's not the plaintext letter you want to guess, you have to search the whole puzzle again to erase every occurrence of that plaintext letter you wrote. Obviously, that kind of task screams for a computer program to do the work for you. Furthermore, a computer can quickly search through a dictionary file and suggest to what plaintext words a ciphertext word might translate, based on whatever criteria you decide. So, when I learn a new programming language and come up with projects for myself to get practice writing in that language, I often choose to write a program to help me solve cryptograms. I typically name this program Crypt, short for cryptogram. In this case, because my purpose was to study swing classes, I called this version CrypSwing. Now, I've seen other cryptogram solving programs which are only text-based. They might try every possible solution for one word, and based on each of those solutions, try every possible solution for another word, and so on. That approach can often be a good beginning, but I find many such programs leave a lot to be desired. What if one of the words in the solution isn't in that program's dictionary file? What if another word that fits the pattern is in the dictionary, so the program takes a wrong turn? What if there are many possible solutions in which the words fit but don't make sense when put together? I feel the need for a human user to intuit what direction to take and to guide the program accordingly. And to help that human user do the job quickly and easily, I feel the need for a graphical user interface. So, let's run it. First of all, I'll just mention that even if you don't want to bother typing up a whole puzzle on your computer, this program can still help you by searching individual words. You can simply hit the Solve Word button, and you'll get an interface to examine one ciphertext word. I can enter one here and now. And find all the words in the dictionary that fit that pattern by hitting the Solve button. I can search through these 21 results and try to guess which one is most likely, but there are ways of narrowing it down. For instance, I can check the like exclusion option. Like exclusion is my own personal term, meaning that a letter cannot translate to itself. For instance, a ciphertext A cannot translate to a plaintext A. Several people have pointed out to me that there's no rule that like exclusion must apply to a cryptogram. However, I've never seen a professionally published cryptogram that didn't have like exclusion, so I see no reason not to check it, especially when it can narrow down the possible answers. So now that it's checked, when I hit solve, the program has narrowed the results down to 11 possible words. Another thing I can do to narrow down the possibilities is to tell the program that I know, or assume, that one certain ciphertext symbol translates to a certain plaintext letter. For instance, suppose I've been working on the puzzle and decided that a ciphertext Y is an E in plaintext. I enter my plaintext E over the ciphertext Y and hit solve. As you can see, that guess really narrowed it down. I should also mention, for those of you without experience in solving cryptograms, that when choosing a word to solve early, it obviously helps if that word is long, but something even more important is to find a word with many repeating letters. I'll demonstrate. I'll hit clear to clear all the ciphertext and plaintext that I entered, and enter even a short word with repeating letters. As you can see, even without like exclusion, I get a short list. So this single word solver window alone provides the heart of my program, but of course, Crypt can do more than that. And by the way, in case you were wondering about that use puzzle option, I'll get to that eventually. But right now, it's useless because I haven't entered a puzzle yet. But for now, let's go for a whole puzzle. Here's a file in which I typed up a few puzzles from an old cryptogram magazine. Now, a longer puzzle is generally easier to solve than a shorter one. A longer puzzle is more likely to have good starting clues and to have more useful cross-references to narrow down the possibilities even more. So I'll copy that puzzle. Now in my puzzle solver window, I'll hit populate puzzle and paste in the ciphertext. You'll notice that here too we have a like exclusion option, although I've found that when Crypt makes its initial guesses, like exclusion makes little practical difference. So I'll just hit OK. As you can see, CrypSwing has populated almost the whole puzzle, leaving us just a little bit of work to do. It's obvious that M translates to Y, so I'll just click on the plaintext space above any M. Now, when I hit the Y key, Crypt will translate every M throughout the puzzle to a Y, so that in more difficult puzzles I can instantly see what consequences my guesses would have. Well, in this case, they're not even guesses. They're obvious choices. So for a real demonstration, let's try a harder puzzle. Uh-oh. Clearly, Crypt made some bad choices in its initial guesses here. This puzzle calls for a great deal of human intervention. By the way, if I felt that only some of Crypt's choices were bad, I could delete parts I dislike. For instance, if I thought the R didn't translate to a B, I could delete that. And the B above every R would disappear. Or, for another example, if I thought the word couldn't should be wouldn't, I could just type a W here, and Crypt will show me the consequences. But in this case, it's obvious the solution was built wrong from the ground up, so I'll hit clear. By the way, notice that the bottom of the window gives us a frequency count of all the ciphertext letters, first in order of frequency, descending, and then alphabetically. That can help us make guesses. Now, From what I just saw, it seems unlikely that the apostrophed word was a not contraction, so I'll guess that it's an apostrophe S. With that assumption in mind, it's obvious that this word must be as, is, or us. Well, is the most likely, so let's guess that. I just made 2 questionable guesses, and I'm still far from solving it. I need help from Crypt. I noticed that this word has 2 letters with values we're assuming, so let's try that. When I click on any plain text space over that word and hit Solve Word, the single word solver window automatically populates with the ciphertext and plain text that I guessed. I hit Solve, and Crypt gives me 12 suggestions, some of which are more likely than others, as a human user would know, so we can skip the unlikely ones for now. To make a guess quickly and easily, I can double-click a result. Let's guess dispute. No, that translates a 2-letter word to PU and begins another word with PD. Let's try disrupt. No, that's just as bad. Okay, let's try history. Ah, now you're talking. This word is obviously that. This word is obviously the. The author of the quote is obviously Henry Ford. And from there, more clues fall into place. Now, let's try an advanced puzzle from the part of the magazine labeled Expert section. Once again, Crypt's guess was a dud. Let's clear it and start from the beginning. Well, this word is somewhat long and has 1 repeating letter anyway, so let's try that. Let's narrow it down with like exclusion. 155 results. That's still too many for my taste, so let's look at the frequency counts. There are 8 R's and 7 L's. No letter occurs 6 times, so let's guess, for the time being, that either R or L translates to an E. Let's start with R. And try some popular words. Belief? Well, that first word looks unlikely, but let's search for that. Oh yeah, you can open multiple word search windows simultaneously and compare them side by side. Nothing. Meager? That also looks unlikely, but let's try that too. No. Relief? No, that gives the same result as belief. Secret? Nope. Of course, we could try unlikely looking words, but first let's try the idea that L is E. Okay, at least there are fewer possibilities to consider here. Anyone? Ooh, never. Let's go with this guess for a while. This word looks like involved. Now, what about this word? There are 9 choices, but I've already based this on so many guesses, it would be nice if we could eliminate some of these possibilities. For example, we guessed that X is I in the puzzle. Too bad we can't just have the program eliminate any word that translates any other letter to an I, or any other letter in our solution. Oh wait, we can, by checking Use Puzzle. And we tell Crypt to use the known ciphertext in the puzzle. Ah, now we have only 2 possibilities, and change seems more likely. I think I can take it from here. And you can take it from here too. Feel free to play with the features. And here's a bonus. In this version of CrypSwing, I'm including a program to do the reverse. Generate a cryptogram from plain text you provide. I named it by spelling crypt backwards and calling it Pyrc. Just paste a quote in here. Run the program, and Pyrc will generate a cryptogram for you. You can create test cases this way. And there it is. Feel free to peruse my code and feel welcome to give me any feedback on GitHub.